about functional groups. A functional group is a group of atoms attached to a hydrocarbon to give it special reactive properties. So we're going to learn about halides, alcohols, aldehydes, and ketones, carboxylic acids, esters, and ethers. So let's get started. Okay, so first we will talk about halides, and I'm sure you guys are hopefully all familiar with halogens. And a halide is basically when you take a halogen and add it to one of your carbon atoms in a hydrocarbon. So let's take propane. There's propane right here. I'm not going to take the time to add the H's just yet. And you just add something like bromine. So, and now we can add the H's. La la la. So, this is just propane, but it's a halide. So, you would name this by calling it, well, there's bromine on it, so bromo propane. Easy, right? Bromopropane. And just like when we're naming groups, like where they are, this is on the first carbon, so we don't need to say like one bromopropane. But if the bromine was in the middle, like that, that's really bad. If it was in the middle, and the H is right here, then we would have to say 2-bromopropane. Okay, so let's just do like one more example, and I'll do it another way. Let's draw it like this. So we have CH 2Cl. Let's do another something, CH 2Cl. Alright, what the heck is that? Well, this is 1, 2 dichloroethane. And if you don't believe me, let's try to draw it, because this is like the trickiest way to draw things. So there's 2 C's, only 2. So you can draw that, and then there's an H. It's 2 H's on that C, and then there's also a Cl, and then there's 2 H's on that C, and another Cl. So that's it. Now you can see that it's 1,2 dichloro. You can't just say 1,2 chloro. It's dichloroethane. Okay, and yeah, so there could be chlorine, which would go to chloro, or bromine, bromo. Yeah, so those are halides. Pretty easy. Now let's talk about alcohols. Such as methanol. So when you're naming an alcohol, it has an OL ending. Okay? So that's how you determine, like, okay, methanol has an OL ending. And how would we draw methanol? Well, meth means 1, so there's just 1 carbon, and there's just an OH, because methanol has an alcohols, pardon, has an OH ending. So this looks just like that. That is the simplest alcohol possible. So just to know about alcohol, so they end in OL, and they look like that. Now what the heck is that R thing I just drew? Well, right here, to say R means a carbon chain. So when naming like what the addition is to make a functional group, then we just put R as the carbon chain. So that could be like 5 C's and 11 H's, but we just put R. Get it? I'll talk about that more later. So alcohols, OL and ROH. Let's do one more example of an alcohol. How about, I'll draw it this way. And notice that it's this C right here is bonded to just the O, and then the O is bonded to the H. So we have our C's, and then whatever empty spaces the carbons have, there's an H attached. So this would be some sort of pent because there's 5 C's, and then we do the AN, and it's an alcohol because of the OH. Whenever there's an OH just like that, singly bonded to the carbon, OL, pentanol, and it comes on the second carbon, 2-pentanol. So that's 2-pentanol. I think we're getting the hang of alcohols. Let's move on to another wonderful functional group. How about aldehydes? Aldehydes. What's an aldehyde? Well, so we have our R, our carbon chain, and then C bonded to an H, also double bonded to an O. And this group right here, ooh, Halloween colors, that group has to come at the end of the hydrocarbon. Has to be at the end. Let's try drawing one of these things, one of these aldehydes. Let's do the simplest aldehyde. It's just one C with an H on this side, an H on that side, double bonded to an O. So see, the carbon has all 4 bonds. It's bonded to that H, bonded to that H, and double bonded to that oxygen. And this is the simplest thing. I would think that you would call it, well, normally you would call it methanol with an AL. Notice not methanol, but methanol, because aldehydes have an AL ending, but it's actually formaldehyde, which is like common in Brazilian blowout. It makes your hair fall out, terrible. But formaldehyde, why they named it that, I don't know. It's just the common group, formaldehyde. Or the common name. Did I spell that right? Yeah, formaldehyde. So this is like the standard, like how we would name it, by using all the tools, like that ending and all the ways we've learned to name things. But then lots of chemicals have common names. Not quite sure how they figured out how to name it like that, but formaldehyde. Another example. Let's see here. I'll name it normally. So we have CH3, CH2, and then the CH double bonded to an O. What would this be? Well, prop, because there's 3 C's. Prop, and now propanol, or propanol, I guess you would say. Propanol. Got it? It's 3 C's, and then it has that group. Whenever you see that, then just know that is an aldehyde. And now, talk about aldehyde's cousin, the ketone. It's very similar to an aldehyde. A ketone, the ending is own, not one, but own, and its the formula is an R, which again is our whatever carbon chain we're dealing with, and then just a C double bonded to an O, and another R. And we put a apostrophe here just to show that this doesn't necessarily have to be the exact same R as this. There could be 2 carbons on this side and 3 carbons on that side. But this chain always has to go in the middle of the carbon, or as middle as possible. So, an example would be, where's an example? Let's start this way. Now that looks like a weird way to draw it, but it works. This is, there's 1, 2, 3, 4 carbons, so this is butanone. And we can tell because it's just a C double bonded to an O, and that's it. Simple enough. So those are ketones. Just know that formula, these formulas are key. You'll definitely need to memorize these. What comes after ketones? Carboxylic acid. Carboxylic acid. It's kind of like a mix between an aldehyde and an alcohol. Carboxylic. And did I spell that right? No, I did not. There we go. Carboxylic acid. And symbol or formula for that is we've got our carbon chain, and then it's our C double bonded to an O, and then it's double bonded to an OH. And this also has to be at the end. Okay? Let's draw one of these guys. Let's do CH3, CH2, CH2, blah blah blah, COH double bonded to an O. And that would be butanoic acid. Let me write that out for you. Butanoic acid. So as you can see, the ending for carboxylic acid is oic acid. Even though it's not carboxylic acid or something, that's what it's called. Okay, so we're done with carboxylic acid. Next up, the ester. And if you don't know, an ester is basically anything that sweetens something, like if you have, or like fragrance or something, like that banana smell, or like if you ever smell a banana, there's esters in the banana that causes it to smell. Or perfume in soaps or anything, any scent, that's an ester. Okay, so an ester, I'm not really going to tell you how to draw or how to name esters. It's pretty complicated and there's not a huge structure. I didn't have to know it in school, and hopefully you won't either. But you definitely need to be able to determine that something is an ester. So you'll have your R group to recognize it. You'll have an R and then a CO bonded to another O, and then your other R group. So it's going to be somewhere in the middle, can't be on the end of a hydrocarbon. So you can see something that looks like CH3, CH2, CO double bonded to another O, CH, 2CH, 2CH3. Something crazy like that. And I'm not even going to name this one for you, because I mean, I have no idea what it is, but it does exist. And just because it has that thing, just be able to tell that that is an ester. And again, if you're fuzzy on the whole, what the heck, that R thing, this is an R thingy, and this is an R thingy, but it's different. See, this one's longer. We put the apostrophe to tell us that the two R's don't have to be the exact same. I know I said that already, but I'm just emphasizing. So just be able to tell that's an ester. And a little mnemonic to help you out is, like whether this is an ester or an ether, if you get those mixed up, is ester kind of sounds like Easter, like the holiday with lots of Easter eggs, and this is the only functional group that has two oxygens. Esters, and lastly, or not lastly, but almost lastly, we have ethers. So, an ether, this one's fun to draw. RAR. O-R. That's it. It's just, if you see an oxygen just sitting awkwardly in the middle of some carbons, then that's an ether you're looking at. How do we name an ether? Well, let me go like that. Okay. That right there is an ether, just because we see that weird little O just sticking out in the middle of nowhere like a sore thumb. And how do we draw this? Well, we actually start with the O. We know that it's going to be an ether. The ending is just saying ether at the end. And then, well, we go on one side. Like on this side, there's two carbons attached. Carbon, carbon. So we'll say there's some sort of ethyl group. Remember those YL groups from earlier? Ethyl. Then on the other side, there's only one carbon. So methyl. Ether. And this time I actually left the spaces in between, because these are actually all separate words. This is three different words. Ethyl, methyl, ether. Now, if we had to draw dimethyl ether, dimethyl ether, and remember it's two words, dimethyl is one word and then ether is another word, then we'd start with the O, and there's two dies, or there's di, which means there's two meth groups, which means there's a meth on this side and a meth on that side, and that's it. So that's dimethyl ether. Or we could draw it the other way, where we have the O attached to a carbon and its little hydrogen minions on one side, and a carbon and its little hydrogen minions on the other side. That's the same thing. And the reason why this doesn't have all four carbons is because it already has 6 valence electrons and it only needs 2. 1, 2. So that's why it's just hanging on by 2 bonds. So that's dimethyl ether. And that is it. Lastly, we just have to talk about the aromatics. Okay, just to recap, here are all the different functional groups that we've covered and their names. We've learned about alkanes, alkenes, alkynes, halides, alcohols, aldehydes, ketones, carboxylic acids, esters, and ethers. Wow, we can pack a lot into just an hour. Oh, and one thing I didn't mention is that any group of a C double bonded to an O, you can see there's a lot of those, like in aldehydes, ketones, carboxylic acids, and esters. This right here is called a carboxyl group. Let me write that just right here. Carboxyl group, pardon my writing. Okay? So carboxyl group is just any C double bonded to an O. So this has a carboxyl group in it and blah blah blah. So this is just like a good chart that you can make, really helpful for studying. So you can pause on this if you need, copy that or whatever. So that's that. Okay, we still have a couple more things to go over, a few other things that I left out, such as what an N in front of a hydrocarbon means and what isomers are, a little something about unsaturated fats, residue, and amines and amides. So we'll just go over that real quick before we start talking about functional groups. So whenever you have an N in front of a hydrocarbon name, like if you were given N pentane, what is that N? Well, it's really rather pointless. The N just means that the hydrocarbon is in a straight line. So this pentane would just be like that, 1, 2, 3, 4, 5. So that's N-pentane, and then you draw on your H's. I'm not going to do that. And the reason why they put this N is just to specify and remind you that this is a straight chain, because pentane has several isomers. Now what is an isomer? Well, an isomer is something that has the same structural formula. So if you take pentane, which is C5H12, that's pentane, then the different isomers of pentane all have 5 carbons and 12 H's, but they're drawn in different ways. And we'll do an example with hexane. So hexane is C6H14, and you can draw it several different ways and it'll still have the same formula. So one way is like this, 1, 2, 3, 4, 5, 6. So that's just the simplest way, and it's just called hexane. And if you would add up all the carbons and hydrogens, you would have 6 carbons and 14 hydrogens. You could also draw it like, let me use a different color. You could draw it like this, 1, 2, 3, 4, 5, like that. So if you added up all of the C's, 1, 2, 3, 4, 5, 6, and then added up all of the hydrogens, there would still be 14, even though it looks different. And we would call this 2-methylpentane. And 2-methylpentane is an isomer of hexane. So that's a second way to draw it. Another way to draw hexane, to draw this formula C6H14, would be just like this. You have your 5 again, but this time you put it in the middle. So there's still, if you count it up, there's still 6 carbons, but this would be 3-methylpentane. But it's different because it's in a different spot. This extra ol is in a different spot. So that's another way to draw it. Can we think of other ways to make something that has 6 carbons and 14 hydrogens? Well, here's another way. Go like that. So there's 4, like butane, and there's 2 branches. And this would be called 2,3-dimethylbutane. Sorry about my handwriting. So it's 2,3-dimethylbutane. If you added up all the C's and H's, you would still have C6H14, but it's called something different. And can we think of anything else? Well, there's one more thing. Hang on, so that was the 4th way. And the 5th way would be, you have your butane parent chain again, and you put these two branches both on the second carbon. So this would be 2,2-dimethyl butane. So understand there's 5 total isomers of C6H14. They all have different names. They can also be called something like this is also known as commonly isohexane, which just means it's an isomer of hexane. And this original hexane, we can call it N-hexane, just to specify that it's not any of these. We want you to draw it straight like this, just with no branches. Get it? So those are isomers. Let's try one more isomer, because in school, like, a question could be like, draw all the isomers of butane, and you just have to figure out what are all the ways that I could make it so there are 4 carbons and 10 hydrogens. Let's try finding all of the isomers of pentene with an E-N-E. Pentene. So let's just draw a normal pentene, which would be C and then a double bond because of the E-N-E. And there's 5 carbons. 5 carbons. So that's the simplest way. And then I'm not going to draw on all the H's, but remember that there's all these H's. And there would be, let's see, the formula is CnH2n, so there would be 5 carbons and 10 H's. So this is the first way. It should just be N-pentene to specify that it's a straight line. Another way would be 2-pentene, and we would draw that by putting the double bond on the second carbon. So this, and again, I'm not going to draw the H's. So 2-pentene, because it's in a different spot. What's another thing we could do? How about we could draw it like this, where there's double bond on the first thing. And we could do a carbon like that, and that would be an isomer of C5H10, and it would be called 3-methyl pentene. And you might be wondering, well, why isn't it called 2-methylpentene? Because you can make it a lower number if you start with this C. But like I said before, you have to get to the double or triple bond first. So we have to start from this side so that it can be 1-pentene. And that's why this is on the third carbon, not the second. And one last way, you could, I know there's another way. Oh yeah, you could go like this, and believe it or not, that I'd still have the same C5H10 formula, and it's called 2-methylpentene. And this is all one word. I'm just putting a dash to say that it's one word. 2-methylpentene, and that's because this could be the parent chain. Remember, the parent chain doesn't have to be in a straight line. You could go like 1, 2, 3, 4, and then on the second carbon is that methyl group. So there's no other way to draw C5H10. So those are the 4 isomers of that formula. Okay, so those are isomers real quick. We can get rid of that. And just a quick word I wanted to say about unsaturated fats. I know I talked about them already, but just know, because think we all know that unsaturated fats are better for you, and that's just because the double bond, because remember, if there's a double bond then it's not a saturated hydrocarbon, the double bond makes unsaturated fats easier to digest, and it makes it less likely to coat the inside of your arteries. So that's just a quick word on unsaturated fats. R, remember how I said R just means carbon chain, like if you had something like that, and remember that's an ester. I told you that this means carbon chain, just like any old carbon chain, and it actually stands for, if you were wondering, it stands for residue, because it's just the leftover whatever thing the functional group is attached to. So it's just called that, and it also stands for the rest of the molecule. Okay, so that's real quick. And then amines and amides are just a couple other functional groups that I didn't cover, and I'm not really going to give any examples, but just so you know, the formula for an amine is just NH2 attached to the group, and remember N is nitrogen, so that's an amine functional group. And an amide is, so you have your whatever chain and then C double bonded to an O, and remember that's called a carboxyl group attached to an NH2. So just like an amine, the amides also have a double bonded O. Okay, so those are just the other things that I wanted to touch up on. And let's continue. Lastly, we just have to cover the aromatics, and when we're talking about aromatics, we're talking about benzene. Aromatics are substituted versions of benzene, you know, when we substitute hydrogens for other things. So if we substitute the first and second hydrogens, or for something on the first and second carbons, then we have an ortho beginning when we're naming things, and this will make more sense in a minute, so just bear with me. For substituting the first and third ones, then we call it meta. And the first and fourth, it's para. Okay, and this will make sense in 1 second. Okay, I've written those things off to the side, and remember benzene, this little guy? Well, let's say we added a Cl and a Cl with 2 chlorines. Now how would we name that? Well, instead of saying 1,2-dichlorobenzene like you would think, the 1,2 means ortho, so we just say ortho and then the hyphen dichlorobenzene. Okay? That's really simple, right? And sorry if that went off screen, but just ortho-dichlorobenzene. If this were on the first and third, then we would just say meta-dichlorobenzene. So I've drawn it out this way now just so you can see how all the C's are bonded to 1H. And let's take away this one and replace it with a fluorine. And let's take away this one and replace it with a fluorine. And we start counting 1, 2, 3, 4, 5. It's on the 1 and 5. But wait, no, it's not. We can count counterclockwise too. So 1, 2, 3. It's on the 1 and 3rd. So do we say 1, 3 fluorobenzene? No, we don't. We just say meta. Meta hyphen fluorobenzene. And I know I've just added halogens the past 2 times, but do you have to do that? No, of course not. Let's replace those, and how about we stick a C with its 3 H's, you know, a methyl group. This is a methyl group. And let's go 1, 2, 3. Stick one on this one too. Now what's this? These are just 2 methyl groups, right? And they're on the first one and 4th carbon, so we say para dimethyl benzene. Alright, simple as that.